now we're going to take a look at interval notation and set builder notation, which is also called set notation. A couple main things to keep in mind. We're going to talk about interval notation on the board. Parentheses indicate values that are not included, where the brackets, the squared off parentheses, indicate points that are included. So parentheses are always used for this is infinity or negative infinity, okay? So those are really the three main points of interest when we're doing interval notation. And so if we're taking a look at this graph, it's saying circles, closed circles, just to review, closed circles mean that points are included. Open circles refer to points not included. So on this first example, because it is included, that means that we are going to be using a bracket. And the graph starts at 6, so it's going to be bracket at 6. And where does it end? It starts at 6, but it includes 6, so bracket 6, and it's ending at positive infinity. That arrow going on forever refers to infinity because it's going towards to the right of 6, towards positive infinity. And the last bullet point, the last part, says that you always use a parentheses with infinity. So the answer in interval notation is bracket 6, comma, interval, positive infinity, parentheses. Set notation is what actually you guys are most familiar with. It's saying how would you write an inequality that represents this? So x is greater than or equal to 6. But set notation uses the application of braces. Braces are those little squiggly things where we start it as x is a solution such that x is greater than or equal to 6. So yes, you do need the beginning part of that as well, because that's kind of like a complete sentence. If you only leave it as x is greater than or equal to 6, that's kind of like a fragment. You didn't finish it. You didn't write it correctly. Just to help you practice how to write a brace, one way I explain to people to do that beginning one is you draw an S, and then you draw a backwards S, or like a sloppy 2. And then you switch them to do the backwards brace. So you write a sloppy 2, and then an S. And there you have your braces. Feel free to practice. Okay? So we're going to go ahead and do that for the rest of the example. So we're going to come over here. We're going to do interval first. So it starts at -2, and it ends at 5. So we just have to figure out bracket or parentheses. Because it's open circles for both, that means it's parentheses because those points are not included. And then set notation, you always start with the brace. X is a solution such that bar means such that. And then you have to figure out, well, x is between -2 and 5. So this means that we have compound inequality. And we use just the less than symbols for both because those points are not included. So the way you read this, the arrows will always, always, always point to the right because x is in the middle. It's saying x is greater than -2 and x is less than 5. Okay? So that's why the arrows always point the same direction. You just have to decide if there's a bar underneath it or not, if it's equal to or not. So with this next one, we have -7 to 0. It does include -7, so that's a bracket, and it does not include 0, so that's a parentheses. And there's your interval notation. Set builder notation is x is a solution such that, well, we are between -7 and 0, and x is greater than or equal to -7, but less than 0. Okay? And then this last example, wait a minute, there's no points. What the heck? So that means in interval notation, you're going from -infinity to positive infinity, which are 2 parentheses. In set builder notation, we call that all real numbers. And you can leave it like that. I know you could actually put it formally as x is a solution such that x is all real numbers. But I'm okay. I just really want you to understand that solid line means all real numbers. So now what we're going to do is I give you set notation, and you have to give it to me in interval notation. Give me the answer in interval notation. Okay? And then also graph it. So Let's go ahead and graph it first. Some of you guys are more visual. So we have 5 shaded in because it's and equal to going to the right. So there's our graph. And then in interval notation, it includes the point 5, but it's going towards positive infinity, which is parentheses. And part B, notice that the first symbol does not include the point, so that's parentheses, starting at -10, ending at 4, which does include the point number 4. And then I'm going to go over here in my graph, and I have -10 and I have 4, but 10 is not included where 4 is. So that's a shaded circle, and it's all the points in between. And then C is all real numbers, so that is -infinity to positive infinity. And remember, you want to shade your entire line. Make sure you guys scribble and squiggle lines well marked. If you just do one line on top of the other lines, I'm not going to be able to tell where your shading is, and that would be marked wrong. So make it very, very evident, very clear, so that's why you see me scribbling very clearly where it should be shaded in. Last one, express each interval in set notation and graph it. So this time we're going backwards. So this is going to be a compound inequality because it's giving me 2 points, there's no infinity in it. So if I graph it, I have the point 2.5 and the point 4. The brackets indicate the points are included, which means that they're both shaded in, and all the points in between. So your set notation would be x is a solution such that x is greater than or equal to 2.5 and x is less than or equal to 4. In part B, we're going to start with the set notation this time. X is a solution such that I know it's going to be between -2 and 5. X is always in the middle. But it's including -2, so x is greater than or equal to -2, but x is just less than 5. So my graph for that would be -2. I include that point, so I shade it in. 5 is not included, so I just leave an open circle, and I shade everything in between. So rule of thumb, if you're given 2 distinct points in interval notation, you know that it's going to be a compound inequality with 2 solid endpoints. Part C, however, has a negative infinity in it. Whenever you have a negative infinity, that's going to look like it being shaded one side, one direction of the other point. So, whoops, let me draw my graph, be consistent, draw it over a little bit. So I have the point -1. And because -1 has a parentheses around it, it's going to be an open circle. But then I look and see, okay, so it's going towards negative infinity. That's to the left of -1, so I'm going to shade to the left. That's where all the negatives keep going. So in interval notation, in set notation, you have x is a solution such that, and this is red, x is less than -1. At -1, it's all the points to the left are less than -1. And that's it.